Did it say it was recording? I couldn't hear. Is that recording? Okay, good. All right. Okay, quiet, everyone, please. Quiet. Okay, we don't have much time. Oh, great. I'm fogging my glasses. All right, so I have this fancy microphone that I bought so I could do Zoom calls during COVID. So hopefully that will work. I think the problem is that something in this building is interfering with the Bluetooth. So I'm going to have to stay over here for the most part. So let's take a look at where we were last time. We had this MyListImpl class. All right. My computer is being slow. That's just what I needed. All right. So this is the same code I showed you yesterday or last time, but I've added a few things to it. So one of the things I added is prepend. Okay, so prepend means I want to add something on the front of my list, not at the end, right? So what I do here, right, first thing I do is I increment the logical size, and then I call grow, because I have to make sure that there's enough space in the array to do what I need to do. The next thing that I'm going to do is I'm going to copy the data one cell forward, right? So I'm going to take the data that's in I, and I'm going to copy that to I plus 1. But if I do my array the normal way, if I iterate I forward, right, what's going to happen is I'm going to overwrite my data. I'm not going to get the correct thing. So I'm going to start at logical size -2. I'm going to continue as long as I is greater than or equal to 0. And then my iteration step is going to be I minus minus. And then I copy the data. And then finally, I stick the data into array element 0. Does that make sense to everybody? Does anybody have a question? Yes. Name. Taylor. Yes, I'm moving backwards through the array. I have to do that, otherwise I would overwrite what I did, right? If I went forwards, every time I did it I plus 1, I'd copy the same value. Yes. You have to use your name first. True. All right, so I'm sweating, of course. So I start at logical size -2, because remember that the last element in the array is I minus 1, right? So logical size -1 would be the last element in the array. And I incremented it by 2 before I started. So that's why. I mean, I didn't increment it by 2. I incremented it by 1, but that means there's 2. You knew what I meant. All right. Okay, so that makes sense to everybody? Thanks to these two guys for asking questions. All right, the rest of you benefited. You always benefit because, you know, the more you let me talk, the more stuff I teach you, the more stuff I can test you on. Just keep that in mind. What is your dog's name? I walk my neighbor's dog. It's much better than having your own. Her name is Elsa. All right. And I also walk a pit bull once a week. That's an exciting adventure. Let me tell you, it's like walking a torpedo. All right. So the next one I'm going to do is insert. So maybe I don't want to put something at the end, and maybe I don't want to put something at the beginning, but somewhere in the middle. Okay. And so I'm going to have insert. And what insert is going to do, it's going to take a position and it's going to take a value. And I'm going to start the same way as I did before, and for the same reason. I'm going to increment logical size by 1, and then I'm going to call grow just to make sure I have all the space that I need. And I know that the array is going to increase by 1 in size anyway, right? Okay, so now what I'm going to do is I'm going to do this same backwards loop, except I'm going to stop. I'm going to say I greater than or equal to pause rather than 0. All right. And then at the end of the array, at the end of the routine, I'm going to fill in pause with the value. All right, so to be more generic than prepend isn't hard. I just have to change one thing. I have to change some zeros to positives. Does it make sense? Anybody have a question? Yes. Yes. So Brad asks if I really need prepend since I have insert, and the answer is no, I don't. What I would normally do, right, if I was coding along at this point and I'd written both of these methods, I would look at my prepend method and I would say, that's dumb. I'll just call insert with 0 as the first argument, and that would be my implementation of prepend. So always try to reuse code and get rid of redundant code. That's a good comment. All right. All right, and then finally we need to test these things. So what I did was I inserted some code to do that. So down here I created my list 2, and then I printed it, and then I did a remove evens, and we saw that. Next, I'm going to do a prepend of the value -1, and then I'm going to print the list again, and then I'm going to do an insert at position 5 of 88. What did I can't quite read it. 88, yes. And then I'm going to print it out again. All right, so Javik, my list. Come on. Info. Java, my list. Okay, so what you see at the end, right? Here's the full array, my list 2. Here is the remove evens. Here is my list 2 with a -1 prepended. And here it is with something inserted, an 88 inserted at position 0, 1, 2, 3, 4, 5, right? And you can see that all the values are preserved. All right, look good? Yes, Drew?
Yes. Is it possible with your list to update a data number and then insert something else?
Yeah, well, we have a set. Right, so what the heck is that commented out code? Oh, I see. That was the code in case I wanted to insert something to set something beyond the end of the array. Okay, so that's going to replace an individual value, right? We could, of course, remove something out of the list or remove something out of the middle of the list. And I'm going to let you think about that one overnight or until the next class, and we'll probably talk about it then. But if you can think about it a little bit first, that might be helpful for you. So how would you implement a remove, and then a remove that takes a specific index? Maybe a remove end. How would I implement remove end? Let's try that one. What would remove end do? Remove the last element. What would be the most efficient implementation of that? Scott?
Search for what the last element is, like what number is the last element of the ordered list, and set it to 0.
No, we don't want to set it to 0. We want to remove it from the list. We want the list to be 1 shorter.
So you would search for the length of the list and set your loop to have I start as 1.
I think
is less than.
You're overthinking. You're overthinking it. You're on the wrong track.
Just figure out the size of the array and then make a new array that's 1 less and then copy the first part of the array.
What's your name?
Logan.
Logan.
Vic, you can find the element you want to remove and set that element to null.
Well, in this case, removing the last element, and we have primitive types, so we can't set them to null. You could, but it's simpler than that. Isaac, yeah. Yes, so Isaac is right, and he even thought of something I didn't. So the way he would implement that is if logical size is greater than 0, logical size minus minus. That's all you need to do. I wasn't thinking about the if greater than 0, but he's right. If you did a logical size minus minus on an empty array, then you get an array of size -1, and that would be very bad. Okay, any questions about that? Okay, so the more complicated ways you were talking about would be best for, if I was removing something that wasn't the last element. But if I'm removing the last element, all I have to do is decrease the logical size. Okay, I want to talk to you about 2D arrays because we are going to have to deal with them at some point, and I don't want your minds to be, I'd rather have your minds blown now than later. There's kind of no point to computers if you can't do that. So I made, I don't really need this, but I just did it because I think it's useful to keep going over the interface paradigm. So I created a my2D-list interface, and that has a get, and I can give it an I and a J to get some places to get the X and the Y coordinate inside the 2D array. And then I have a size X and a size Y method that you can get the size in the X and Y directions. And then I have a set, which gives you an I and a J and a value. Okay. So I don't have a dynamically growable 2D list. I mean, I could make that, but it's just, it's just work. But this is the basic interface that I'm going to provide. So it should all work fairly intuitively, right? You can get, you can set, you can ask it how big it is in each direction. Make sense? We're good so far? All right, let's take a look at how to do that. All right. So the way this code is going to work, right, is I'm going to have some kind of new looking thing here. We have int array array. Okay, so that's how you would declare a two-dimensional array of integers in Java. You can allocate the memory for it by doing this. You can say data equals new int sx sy, where those are the two sizes, and Java will do the right thing. However, as is often the case, Java is doing just some magic for you. What it's doing underneath the covers, as you will, what it's doing, the way it's implementing this, right, is as an array of arrays. So first, what you do is you allocate an array of size sx, right? So this is sx int arrays that I'm storing in there, and then I'm going to fill in each of those arrays with a new int sy. So if you want to think about this, I have an array of pointers to arrays, and then in each of those pointers, I have to allocate an array. And this is what Java is doing internally. Now, if you do it explicitly like this, you could have each X value could have a different length in the Y direction. That would be confusing, but there might be reasons why you would want to do it. Okay. Does that make sense? All right. So now what I'm going to do is I'm going to have my get method, and the get method is just going to be as simple as calling the square bracket operator twice. So far, so good. Then we have a size X, and that's going to be data.length. So that's going to be the first direction of the array. The second direction of the array, I have to get one of the elements of the array and get the length of that. So for the Y direction, I have data0.length. Data0 is the one that's most likely to be there. So, that's the one I go for. Make sense? Okay, and then I have a little main method to test it. All right, so I create a 2D list of size 3, 4. I set the 0, 2 element to 5. I assert that the 0, 2 element is 5. I set the 2, 1 element to 3. I assert that that's true. Then I do this thing where I print out the whole array. Okay. Oh, I should have run it with assertions enabled. Hold on. There we go. Okay. And so there you have it. You have this beautiful array that I made, 3x5 array. Okay. It's all, I hope, fairly intuitive. I hope it's not too mind blowing. It's just, I have a lab that uses a 2D array, and I'd rather you were prepared for it mentally, psychologically, had the appropriate, Xanax or whatever that this provides you. All right. So now don't run. We still got 5 minutes. So the next thing I want to show you is another way to do the 2D array. All right. So we have, in this case, what I'm going to do is I'm going to fudge the whole thing. I'm just going to have a one-dimensional array, and I'm going to pretend it's a two-dimensional array. And this is kind of, this is going to be kind of more efficient in some ways, because remember, we talked about the last way we did it. We had an array of arrays, right? So we had to do one allocation, and that allocation had a list of pointers in it, and each of those pointers pointed to another array somewhere in memory, right? This way, we're just going to have one big block of memory. All right. And that one big block of memory, we're just going to figure out which coordinate goes to which location. So what I'm going to do this time is my big block, I know how big it's supposed to be. It's going to be Sx times Sy. It's going to be the size in the X times the size in the Y direction, right? If it's a 3x5, I need 15 integers to make that work. All right. If I want to get the array, though, this is where it starts to get interesting. So now what I say is I1, so the I value, times ny, the number of Y elements, plus the Y element, okay? So that's going to give me a unique value for each ij pair into that 15 array. You see that? Do you not see that? Somebody have a question? Yes. Yes. Okay. So let's say we have a 3x5 array, right? So nx is going to be 3 and ny is going to be 5, right? If I want to index the last element of that array, it's going to be 2, 4, right? So the way this calculation is going to work is it's going to be 2 times 5, which is the number in the Y direction, plus 4, which is 14. That's the last data element, right, of the 15. You see that? So what it's going to do, the way this is going to work is it's going to go, the first J is going to be for I equals 0. And the second J number of things is going to be for I equal 1. And the third J number of things is going to be for I equal 2, and so on. Right. And this is a slightly more efficient way, as I say, of managing a 2D array than using the built-in magic, because the built-in magic is allowing, it's more flexible. It allows you to have varying length rows if that's the thing you want. But this way is going to have it's going to have fewer memory allocations, and it's going to be a little more straightforward for the compiler. Yes. Yes, let's try that. It implements the same interface and the test code is the same. So let's try that. Let's test and see what the output looks like. Ta-da! It works. It gives you the same exact thing. You will be able to access this code after class. I will put it on the examples just like I did last time. All right, thanks for your attention.